Welcome to Section 1, Understanding C++ Fundamentals Part 2, Pointers and Memory Management. In this video, we're going to learn about pointers and memory management concepts. Computers use memory to store data, and to execute code, and to function, just in general. Computers also use RAM, or random access memory sticks, to handle all of this memory. The smallest measured size of memory is 1 bit, or a single binary digit, which can be 0 or 1. On the right is a list of the different units of measurement for computer memory, starting at 1 bit and ending with GOP byte as the largest established unit of measurement for memory. Variables use data at different sizes that the RAM will automatically place into empty spaces in memory, depending on how much memory the program is allowed to use. An example would be, say here is our memory. Our memory has 10 bytes of available space, and now let's say we have a game that takes up 7 bytes of memory. So now we have 3 bytes of available memory left, but if we didn't have 7 bytes of memory, the game would crash due to memory overload. On the right is a graph representing the amount of space that these common variables use up on both 32-bit and 64-bit machines. You may notice that for chars and bools, there is no change. This is due to them being in exact values. The reason for why 64-bit machines use more memory than 32-bit machines is because they are given more precision and accuracy for the results of these variables, thus requiring more memory. Strings are not taken into account for this graph due to them being an array of chars and thus can range in size. Each location in memory has an address that is read typically with a 0x and then a bunch of seemingly random numbers and letters that will actually translate into binary. This is a beginner course, so we will not be learning how to convert hexadecimal, but it is important to understand that this is an address in memory. RAM will automatically segment out locations in memory for variables and other data. An example would be, say here's our memory, which each byte having its own location in memory. We have an integer that takes up 4 bytes of memory, and this integer is given its own address in memory based on the address it took up. This is all done by RAM automatically. Pointers are one of the most important features about C++ to understand. Pointers use a variable type that always takes up 4 bytes. Pointers are used to go to a location in memory or to get the actual address and can only point to one variable type when declared. When declared, if they are not set to an address, then they are immediately null pointers. An example would be, as shown, we have a player class instance, and you want to get the address of where that player instance is located in memory, so we would use a pointer to do so. The way you would declare that pointer is player class as the variable type, then a star, then a space, and then the name of the variable, so in this case, player class pointer. So why use pointers? Well, they are incredibly fast compared to direct references, and they allow us to pass data around at incredibly fast speeds. They allow for dynamic memory allocation, which is great for a game development environment, as we would need to spawn and despawn objects constantly in games, and having something that handles that is perfect for game developers. Dynamic memory allocation is a form of memory management that allows the programmer to request for more memory from the computer to use while the program is running. When using pointers, they allow for the program to request for an available space in memory that the pointer's variable type can hold while giving us an address automatically. They allow for us to dynamically load and unload content while the program is running, and thanks to advances in technology, we have a large amount of space to work in because of this. They are also known as garbage collectors, which take up pointers and other data which can no longer be needed and collects them up and deletes that data, which makes those spaces in memory available for use. An example would be, say we have a garbage can. This would be our representation of pointers and other data that has been marked for garbage collection. In this case, the garbage truck is the garbage collector picking up all of the data that has been marked for collection, and will be taken to be deleted and clear that space in memory or spaces in memory to be used again later on, or in the example of the garbage truck, taken away. In summary, for this course we have installed and set up Visual Studio and Unreal Engine 4, learned about variables and variable types, methods and /functions, classes and structs, what private, public, and protected keywords are, and what pointers and memory management in C++ are. In the next section, we will be understanding Unreal Engine 4.